Welcome grade 8 to another video. In this video we're going to start taking a look at one of the classic things talked about in math. And it's one of the things that we call the Pythagorean Theorem. Now that has a big fancy term to it. It may already be a term that you've heard before. And it was created by a Greek philosopher called Pythagoras, who, when working through math, he saw that there was a connection between some of the distances or measurements of right-angle triangles. So it's all about right-angle triangles. And so when it comes to a right-angle triangle is a triangle that has a right angle. And a right angle we show by a little box, and that right angle is going to always equal 90 degrees. It represents a right angle here. And there's some interesting bits of information that he was able to figure out about some of the relationships here between right angles. And he came up with what's called the Pythagorean Theorem, which is a formula that we're going to use to solve for side lengths of right angle triangles. So with this bit of information, we have different side lengths, let's say A, B, and C. And it really doesn't matter about A and B, but C here is always the longest. And the longest side length is always going to be opposite of that right angle. And that longest side length has a special name to it, which we call the hypotenuse. So that C is going to become very important when we're solving these particular triangles and we're solving these values. In a right angle triangle, this side squared plus this side squared will always equal this side squared. So A squared plus B squared equals C squared. And this is that Pythagorean theorem, that main bit of information that will help us to solve for missing side lengths. So no matter what, if I know this length and this length, I can figure out this length. And actually, we're going to learn how we can rearrange the formula that as long as we know two side lengths in a right angle triangle, we can solve for the third. This is very important as we're looking for missing side lengths. This is something that, as we're going to see later on, is very applicable also to real-world situations, whether you're doing construction, building something, designing something. We use triangles a lot, and so to figure out missing side lengths is going to be very significant as well. We're going to start stepping through some of the examples here, as I find the best way to understand the Pythagorean theorem is to put it into practice in order to solve for some of these missing side lengths. So let's go through. Let's see if we can do that in these questions here. Let's go through some of the examples. Let's start with example 1. Example 1 gives us a particular right angle triangle. It tells us that this side length is 4, that this is 3, and we are asked to find the length of AB, or to find the hypotenuse in this example. Using our Pythagorean theorem, we're going to do A squared plus B squared equals C squared. So A, we can think of A as 4 or A as 3. It doesn't matter because we're adding them together. If you have 3 as your A and 4 as your B, that's totally fine. The only thing that really matters is that C is your longest side length, your hypotenuse. That's the main thing that matters there. Your A's and your B's, you can switch them up. That's fine. So 4 squared plus 3 squared equals C squared. Remember that squared does not mean times 2, it means times itself. So 4 times 4 is going to be 16. 3 times 3 is 9 equals C squared. 25 equals C squared. Okay, I'm getting close. I now have the answer for C squared, but I need the answer for C, not for C squared. So in our algebra, when we want to get rid of something being squared, the opposite of that is what's called square root. And you could plug that into your calculator using this particular symbol here. These cancel out. We now get c by itself. The square root of 25 is basically asking what number times itself equals 25. And if you plug that into your calculator, you'll be able to see that 5 is the square root of 25. Or to think of it backwards, 5 squared is 25. And so this missing side length c, using the Pythagorean theorem, would now equal 5. Let's do example 2. In example 2, you're given another right angle triangle. This one is quite a tall one, but it's still a right angle triangle that we can work with. We are given the side length here, and we're given the side length here, and we're asked to figure out this missing side length. The tricky part here is that remember that this, or 25, that's the hypotenuse. So it's going to change around our question a little bit. Doesn't matter whether you think of this as A or B, I'm going to think of it as A. So A squared plus 24 squared equals 25 squared. If I wanted to rearrange this and bring this over to this side, A squared equals 25 squared, the hypotenuse, minus 24 squared. That's my side length B. Okay, let's start plugging what we know into our calculator. So 25 squared would be 625. 24 squared is going to be 576. When I subtract them from another, so 625 minus 526, I'm going to get 99. Sorry, not 99. I should get 49. And then the square root of that is going to be my A value, or my missing side length. And the square root of 49 is 7. So my missing side length here is 7, which is my answer here, my way of solving that particular question. Okay, let's go through example 3 now. In example 3, we have multiple parts, or 2 parts to this question. Well, we're given actually 2 kind of triangles as well. So we're given a triangle here, but then inside that triangle we have another triangle. We're told that this is 10, this is 15, this is a right angle, and this is 24. First, we're asked to figure out this side length here. Okay, so we're just dealing with this right angle triangle to begin with. This is A, this is B, whatever you want. This is 24. So 10 squared plus B squared equals 24 squared. Right, our hypotenuse is always that longest side length, always the one opposite the right angle. Let's bring the 10 over to this side. So really B squared equals 24 squared minus 10 squared. B squared equals, we already figured out from our last question that 24 squared is 576. So 576 minus 10 squared is 100. B squared equals 476. Let's take the square root there. So the square root of 476. This one is going to give us a little bit of an odd number. This is one of the first times where, yeah, we have a decimal that we're going to have to do some rounding here. So if we do some rounding in this question, let's just round it to the first decimal place. We're going to say that B equals 21.8. On your calculators, you'll notice that it's a much larger decimal number, but we're going to leave it there for simplicity's sake. Next, we're asked to figure out a B, so this one here. Okay, well, if we think about this whole big thing as a right angle triangle, we can do that as well. We have a base here, which is 15 plus 10, or 25, and we just figured out that this is 21.8. Okay, so 25 squared plus 21.8 squared equals c squared. So let's again plug in what we know. 25 squared is going to be 625 plus 21.8 squared is going to be 475.24 equals c squared. Add those together, and we get 1100.24. All left to do is take the square root of that, and we have our answer. So the square root of 1,100.24 would give us about 33.2 for our side length. Another thing to check as we're going through is, remember, hypotenuse should be the longest. So here 24 is longer than 21.8 or 10. That makes sense. Here 33.2 is longer than 25 and 21.8. So that makes sense as well, that our C is our longest side length as we go through. So we had to do some rounding in this particular question, but regardless, we can still use our Pythagorean theorem to solve it. Hopefully that helps as you step through. Try it 1, 2, and 3 on your own as well.